Now let's look at linear programming using word problems. So this question says you have $36 to spend on tomato and cucumber plants. A tomato plant costs $2 each and a cucumber plant costs $3 each. You don't want to buy more than 15 plants. Each tomato plant yields 8 pounds per plant and each cucumber plant yields 10 pounds per plant. Plant. And you want to maximize the amount of harvest. Question is, how many should you buy of each plant to maximize the yield? So remember I said that every time you solve a word problem, you want to look at the question stem. So the question says, how many of each plant? So this is really what we want to solve. Now, how can you tell how many of each plant? Because you want to buy the amount of plant that will maximize the yield. All right, so what we want to do now is knowing that we are looking for how many of each plant, we're going to create the appropriate variable. So we know that there are two types of plants. There's the tomato and the cucumber. So let's call tomato X and cucumber Y. And there are a few things going on in the problem, right? Okay, so pretty much I would say that up to this point, if you just don't look at that point, that sentence, you can kind of look at it as any other word problems that you've solved before. For example, the first sentence says, you have $36 to spend on tomato and cucumber plant. And then it says the tomato plant costs $2 and the cucumber plant costs $3. Okay, so from here, can you create a list of constraint, or can you create a constraint? Yes, you can. So tomato costs $2 each, so that's 2x. And then cucumber plant costs $3 each, so that's 3y. And then you only have $36 to spend. Now, you don't have to spend all $36, right? It just says that you only have $36 to spend. So what we can say is it's less than or equal to 36 because we don't have to spend all $36. The third sentence says you don't want to buy more than 15 plants. So that just means x plus y is less than or equal to 15. You don't want to buy more than 15. You can buy up to 15. The next thing says each plant yields 8 pounds per plant, and then each tomato plant yields 8 pounds per plant, and each cucumber plant yields 10 pounds per plant. Well, that doesn't really have a constraint, so we're going to ignore that for now. So a list of constraints, first we have the cost. We can't spend more than $36, and then we don't want to buy more than 15 plants. Now there's a list of implicit constraints. Implicit constraint are just the ones that, even if no one tells you, you would assume those are there. For example, they have to be actual positive numbers, right? X greater than or equal to 0, y greater than or equal to 0, because we're talking about buying plants. We're not going to have negative amount. So we're only going to look at greater than or equal to 0 or 0 or positive numbers. So this is our list of constraints. So basically whatever we find as the answer has to fit all 4 of these constraints. Next, we're going to graph and find the vertices. So let's go ahead and graph these. So I'm going to change this to y equals mx plus b, so it's easier to figure out how to solve it. So divide by 3, y equals negative 2/3 x plus 12. All right, so we're going to start at 12, and it goes down to over 3. Down to over 3. And then draw a line. And this is less than, so we're going to shade it down. And then the other one, x plus y is less than equal to 15. So that is just really the y equals negative x plus 15. So we're going to start at 15, and it goes down 1 over 1. I'm drawing a lot of dots because it's hard for me to graph on this program. Okay, and this one is shading down as well. And then the last two are just saying basically first quadrant only. So we can see that the intersection is right here. So this is basically saying everything in here will meet this constraint, this list of 4 constraints. Now, which one is going to maximize the yield? Well, we need to find the actual objective function. So let's find the vertices first. So remember, we always write a list of vertices, oh, vertex, and then, oh, I'm sorry, let me make this look better. Vertex and objective function. So vertex, in this case, we can see that there's apparently 0, 0. If you're not sure where the other points are, you can always just try to solve for the intercept, but I know this point is 15, 0. This point was our y-intercept, and our y-intercept was at, was it 12? So 0, 12. And then we have where the red and the blue inline intersect. So what I can do if I want to make sure that I get the correct answer is I make the 2 lines equal to each other because we're trying to find an intersection. Remember, that's, when we make 2 things equal to each other, we're just saying, where do they intersect? So I'm going to multiply this by -2 and then use elimination. So 2x plus 3y equals 36, minus 2x minus 2y equals minus 30. So that gives me y equals 6. And then plug it back into any one of them. I'm going to plug it into this one because the numbers are smaller. So, I'm sorry, x plus 6 equals 15. So x is equal to 9. So we know that it's also intersecting at 9, 6. All right, the last thing is objective function. So from the last part of the problem where we skipped, that is really the objective function. Because if you ask yourself, what is the objective of this problem? The objective is to maximize the yield. So how do we know how much yield we can have? Well, it tells us that every tomato plant you buy, you end up with 8 pounds harvest. And then every time you buy a cucumber plant, you yield 10 pounds per harvest. So really the objective function, P, is equal to every time you buy a tomato plant, you get 8 pounds. And every time you get a cucumber plant, you get 10 pounds. So this is your objective function. Now plug it in. Obviously, if you don't buy any plant, you won't have any harvest. 15, 0, if you plug that in, you get 120. 0, 12, you get 120. 9, 6, you get, let's see, 132. So this is the one that's going to give you the maximum yield. So 9 tomato plants and 6 cucumber plants. All right, let's have you practice. So this is a little tricky problem. So let's look at it together. You are screen printing t-shirts and sweatshirts to sell at a fair and are working with the following constraints. You have at most 20 hours to make shirts. You want to spend no more than $600 on supplies. You want to have at least 50 items to sell. So these are the constraints, 3 constraints. And then also, they give you some more information. So for example, t-shirt costs $4 to make each shirt, 10 minutes to make each one, and then you get a profit of $6 each. For sweatshirts, it costs $20 to make it, 30 minutes to make each one, and then you earn $20 on each shirt. So first thing is write a list of constraints. Write a list of constraints, but be careful. This one is in hours. This is in minutes. And then use decimals to graph. So what you want to do is once you write your list of constraints, for example, we have the x greater than equal to 0, y greater than equal to 0. That's the implicit given. So what you want to do is type in your constraints in decimals. And what you want to do is try to type in one at a time and be careful of the color because it's shading as as you type it in. If you just kind of don't look at your graph as you type in, then at the very end, it's just a mess. So I would strongly suggest that you type it in slowly and then look at your graph as you're typing it in so you know exactly where the final overlap is. And then use decimals to find the vertices. And then you want to find the objective function and then find the quantity that's going to maximize the profit. So let's go ahead and have you pause the video, and then after you write just the constraints, come back and check the answers. All right, go ahead and check your list of constraints. You should have 5. So 3 from the problem and 2 implicit constraints. Now what you're going to do is graph these in decimals. Since we're going to do this in decimals, it really doesn't matter if you don't put it in y equals mx plus b form. Just graph it and then find the vertices. All right, so this is what happens after you graph in decimals, and hopefully you're getting the same picture as me. So you can see that the overlap for the 5 constraints is this one here. And notice how I don't put in the x greater than equal to 0 and y greater than equal to 0 because I know it's going to be in the first quadrant, and putting those two in makes the colors so messy I can't see anything anymore, so I just don't put them in and just know that it's going to be in the first quadrant. So you can see that there are 4 vertices here, and so I'm going to write those down. Vertex. So I have 25, 25, 50, 0, 75, 15, and 120, 0. And then now we need to find the objective function. Remember, objective function is the objective. So what is the goal of this problem? The goal of this problem is to make profit. So then the objective function is, or equal to, sorry, $6 per t-shirt and $20 per sweatshirt. So then we just put these vertices into the objective function to check. All right, as you can see, this one is going to give me the highest profit. So when I make 75 t-shirts and 15 sweatshirts, I will have the most profit.